This video is on section 2.2, the dot product. It is the first, last, and only video from section 2.2. So I've put everything from section 2.2 into one video. So first of all, we have definition 31, which is a definition of the dot product, sometimes called the inner product. And the operation itself is not very complicated. So take a moment, look at that, see what the definition is. And now we will apply that to example 32. We want the dot product of the vector b, 2, 0, negative 1, with the vector w, 1, negative 1, 4. What do? We multiply the components, and then we add the products together. So we have 2 times 1 plus 0 times negative 1 plus negative 1 times 4. And we add these together, and we have negative 2. The dot product is an operation with two vectors, but the result is a number. So I'm going to say this a lot. Dot product is a number. Cross product is a vector. We haven't gotten to cross product yet. So we will get to cross product later in this chapter, but just keep in mind, dot product's a number, cross product is a vector. And theorems 33 and 34, as I've said before, there are things in math that work the way you want them to, and things in math that do not work the way you want them to. I'm guessing that in theorem 33 and 34, those are things that pretty much work the way you would want them to, or the way you would expect them to work. This is a little redundant. Theorem 33 is actually part of theorem 34, if you look at the notes. Definition 35 is of the length, the norm, the magnitude of a vector. It's a square root of the dot product of the vector with itself. Now, keep in mind the dot product of a vector with itself is always non-negative, because essentially what you're doing is you're squaring the components and then adding the squares together. Dot product can be negative, but a dot product of a vector with itself cannot be. It could be 0. Now, this number is going to be 0 if and only if the vector itself is the 0 vector. So the only vector in the world that has magnitude 0 is the 0 vector. Okay. So example 36, we have a couple of vectors. We're going to calculate their norms, or their magnitudes, or their lengths. So magnitude of v is a square root of the dot product of v with itself. So we have 4 plus 0 plus 1, so we have the square root of 5. The magnitude of w is again the square root of the dot product of w with itself, so we have 1 plus 1 plus 16, so we have the square root of 18, which simplifies to 3 times the square root of 2. A unit vector, definition 37. A unit vector is simply a vector of length 1. Proposition 38 is nice. It tells us that if you take the magnitude of a vector, take its reciprocal, so we're assuming the vector is non-zero, of course. So you take the reciprocal of the magnitude of the vector as a scalar multiple with the vector itself, you have a unit vector in the same direction as v. So this vector is not the same as v, but it has the same direction, just a different magnitude. Remember, vectors are given in terms of direction and length. So this vector has the same direction as v, it just has length 1. Example 39, we're going to apply proposition 38. So we want to find unit vectors in the direction of the given vector. So vector v is 6, 8. Its magnitude is 10. 1/10 times v is 1/10 the vector with the scalar multiple of the vector 6, 8. If we want to, we can factor a 2 out, and we have just 1/5, 3, 4. I'm okay with this as an answer. If you want to distribute the 1/5 through here and write this as the vector 3/5, 4/5, that's okay as well. For the vector b, or for b, we have the vector w. So we have the vector negative 1, 4, 6. Its magnitude, norm, length, whatever you want to call it, is a square root of 53. So We divide by the square root of 53. We have our vector -1, 4, 6. So this is a unit vector in the same direction as W. Note 40. Note 40 is instructing you to look at an example from the text. That's example 7 on page 844 of the textbook. Study that example. So that's what note 40 essentially says, study that example. Example 41 is an example from the homework assignment from the text in this section. I will do this in class. So example 41, I will work through for you in our classroom. However, that example will make a lot more sense to you if you study the example from the textbook that I've asked you to.